Radiation can be incredibly damaging. Ionizing radiation has the ability to break chemical bonds, damage DNA, and severely impact cells. These affected cells may die or become cancerous, ultimately leading to severe.
This reminds me of the guy who was in Hiroshima, I think on a vacation with family, survived, went to work in Nagasaki, and had both the atomic bombs hit him. That's some wild stuff. Talk about 1 in 1 billion unlucky, and surviving both of them.
Complications. But what if this same powerful radiation could be used for good? What if instead of harming, it could help by mutating and modifying cells to produce a positive outcome? Not to create superheroes, but to make our food grow faster, taste better, and become more nutritious. This is exactly what researchers hoped to explore post-World War II as more applications to nuclear sciences were being discovered.
I mean, nuclear science is a very interesting part, but like, if we're creating this much waste, and there's another video I want to be watching that's the nuclear waste is reusable, but we're not reusing it, we're just putting it into the rivers, then I'm not sure if it's a good idea, you know?
And while irradiating food seems like it would be something relegated to a time when people were trying to put nuclear reactors in their cars, the research would lay the framework for practices that we still use on our food to this day.
I wonder if it's good for our bodies.
As we learn something new. This is the 4th video in my Atoms for Peace series. While each of the videos can be watched without all of the information contained in the others, I highly recommend going back after and viewing the other 3. But while this video is about the Atoms for Peace movement, it's more specifically
those robots there are very interesting. That used to be my my educational prowess. What I was going to be educated to do was to make robotics, but I wanted to make underwater robotics. So it's automation and underwater robotics was what I studied. But these robots are pretty cool. They've probably got some really good sensors in there. We never got to work with sensors that good.
About a sub-movement called Atoms for Agriculture. But to understand why we would want to flood our crops with radiation, we first have to go back to Gregor Mendel. You may have heard about Mendel's peas back in your middle school biology class.
Yeah.
In 1865, he learned about inherited traits by studying pea plants, carefully pollinating the plants and saving seeds to analyze future generations. He found that traits like the color and texture of the peas could be passed down and would eventually find that he could determine the dominant and recessive traits of a.
So basically, like lab growing people, like you want big, black, strong, big biceps. So all you do is breed with the big, black, big bicep, and multiple generations down, you'll get like massive bicep, big black guys, basically.
A plant and how selective breeding could induce a preferred trait. This process would go on to be used to pick the best crops and livestock and pair them to make even better crops and livestock. But more importantly, it gave us more control. With an increasing level of control over cross-pollination for plants and mating for animals, we could make them better suited for our needs. As World War II
that's exactly
was ending
the problem.
and wartime
it's better suited for our needs, not necessarily for their needs.
Applications were looking for ways to continue their work, the Atoms for Peace movement had a sizable sub-movement arise. Atoms for Agriculture. In fact, studies had been happening on this for decades already. As early as the 1920s, experimentation with the effect of X-rays on plant material had shown that they induced changes that could be passed on to future generations in barley.
Basically, it's just selective breeding, really, realistically. That's just human incompetence. It's still the most ecological energy. I'm sure it is. Maybe tidal water would be better. Like as a fundamental, because there's always going to be tidal water due to the moon. Well, unless somebody blows up the moon, of course. There's always going to be the tides. So I think maybe that would be probably the most ecological energy. Or wind. But the problem with wind is that you have to have the turbines and stuff. That's incredibly expensive. And does kill a lot of animals. Moon is moving away 4 centimeters every year. I mean, I'm sure there's some sort of scientific equation to when the moon will be gone, but for now it's not gone, is what I mean. If you're thinking about it, there's a lot of natural power that we could potentially utilize that's like an evergreen, like waterfalls or tidal waves or wind, if we get to not kill all the fucking animals that come across there. And I'm sure that nuclear power is really good too. I just haven't researched enough to say what the better of all the options are, if you get what I mean. So I will plead ignorance on this one and then continue learning about it, honestly.
The ionizing radiation they found could cause mutation in the DNA of plants. Many plants would die or get tumors, but a select few could get more useful mutations. The atomic age gave researchers new tools and new forms of ionizing
That's it. Nuclear power releases less radiation than burning coal. I'm sure it does, because coal burning is shit.
that they used in the hope that an increased rate of random mutations would find some scramblings of the genome that made the plant a stronger, faster growing, and more disease-resistant version of its original self. In the Gamma Garden at Brookhaven National Laboratories in Rhode Island, established in 1949, plants and seeds had their genomes rebuilt by being exposed to a cobalt-60 source, a totem-like pole in the center of a field planted in concentric circles, with plants ranging from strawberries to sugar maples. By 1958, atomic agriculture had been taken up and—
Wait, hold the fuck up. Didn't they say that some of these got cancer? Some of the plants got cancer. Is it weird that we get cancer if the plants get cancer? If all the fucking life out there, including non-humanoid species, get cancer from these things, is it maybe a bad idea?
in government laboratories around the world. The circular spatial form of the Gamma Gardens was simply based upon the need to arrange the plants in concentric circles around the radiation source, which stood like a totem in the center of the field. It was basically a slug of radioactive material within a pole, so the amount of radiation received by the plants naturally varied according to how close they were to the pole. So usually a single variety would be arranged as a wedge leading away from the pole.
I'd like to know how many of these tomatoes actually died in the, like, did the front row died versus the back rows, and how much the cancer, the amounts of cancer developed in these tomato plants were due to the spacing from the rod. There's a bunch of stuff I don't know about cancer. I'd love to know from somebody who has an education in cancer research. That would be cool.
So that the effects of a range of radiation levels could be evaluated. Most of the plants close to the pole simply died. A little further away,
Well,
they would be
I got
so
to know the answer
genetically
to my
altered
question.
that they were riddled with tumors and other growth abnormalities. It was generally the rows where the plants looked normal but still had genetic alterations that were of the most interest. They were
I'm a big fan of biochemistry and DNA modification. It's a highly misunderstood field of science. It's also a highly contended field of science, because if you want to modify, for example, a living human to make designer babies, it's just stuff that we probably shouldn't be fucking with, honestly. And I'm sure that a lot of the food that most of the food we make today, like the watermelons and everything, are from specific breeding and taking the best of the batch and then breeding that and taking the best of that batch and the best of that batch, and then they got bigger and bigger and bigger, or less seedy or whatever, right? One of the biggest rules are not to experiment on yourself. Why not on yourself? Or are you talking about not on humans or not on yourself, like as a specific person?
just right as far as mutation breeding was concerned. A huge range of plant materials from crops to ornamental plants were tested, including peaches, grapes, blueberries, sugar maples, barley, corn, wheat, violets, and more, all got hit with radiation. By 1962, there were 9 induced mutant cultivars, or different varieties of the same plant. In 1969, there were 77, and 1,200 by 1990.
So basically, they've sped up, or at least made a change to their genetic structure by giving them radiation treatment. That's really the basics so far I've understood.
As of 2008, more than 2,700 varieties resulting from mutagenic experiments have been released. Some were induced by X-rays, and some were from chemical mutagens, but most were from gamma rays identical to those produced in the Gamma Gardens of the mid-century. To be clear though, this wasn't something that the government wanted to hold tightly to for researchers in big farming operations. There was also a strong, albeit short-lived goal for encouraging atomic entrepreneurship. Yes, for a limited time you could apply to the government for your own radioactive cobalt-60 source, and just keep it in your backyard. One man who did was Clarence J. Spies, an oral surgeon and serial inventor who had previously
that sounds like a really
experimented
bad
with seed
job,
irradiation using X-rays. He would have had easy.
I mean, I'm fairly sure he knew what he was doing, since it seems like he was a researcher that did stuff like this. But like, it seems like a very, really bad idea. Chemical modification can be very dangerous. Well, most chemicals are either killing something or destroying something. Let's say it's illegal to do on others, so that's why self-experimentation is just a rule. I mean, I feel like the people that are really curious will end up experimenting on themselves before others. Like, really curious, because you have the consent of yourself, you know what I mean? Like there was a guy, I don't remember what his name was, that started finding a cure for his son in like a disease that basically had no cure, and he just bought all the lab equipment and studied for 2-3 months straight and managed to find a cure by using it on himself. And now his son is apparently cured. So that's pretty cool. But still, if people are desperate enough, self-experimentation becomes the norm, I think, not the rule.
Access to within the dental profession.
In
1957, the Atomic Energy Commission approved his request for a radioactive source. He built it into a concrete block bunker on his property in Oak Ridge, Tennessee, near the federal laboratories.
And then he died of cancer.
Probably sparked his interest in things atomic in the first place, as well as perhaps also the connection through which he obtained his Cobalt-60. And by 1960, he had founded Oak Ridge Atom Industries Incorporated, and was irradiating.
Tell me this does not look like a Fallout New Vegas advertisement. This just looks like straight out of Fallout. Like, Oak Ridge's Atomic Industries, super atomic energized seeds for your benefit. This is exactly what it feels like.
Seeds for sale to the public in packets marked Atom Blasted. CJ was heavily committed to self-publicity, and press accounts seem to be a bit exaggerated, with claims of 10-foot tall tomato plants that produced more than 200 tomatoes. Although radiation sources could produce larger and more bountiful varieties in plants, it most likely wouldn't be a change this drastic. But as early as the mid-1960s, it had become increasingly clear that the grand dreams of the Atoms for Agriculture movement would not be easily realized. Irradiated superplants had not solved world hunger.
Well, irradiated superplants will never change world hunger, because the corporate greed will be the thing that can change it. However, it doesn't matter if you have plentiful of food, if you have plentiful of livestock, if the people who don't have it still don't have it. So it just means a nation can get fatter and more wealthy, and the poorer people can look at you get wealthier and fatter. That's really the difference. The guy from Thought Emporium channel cured his lactose intolerance for 1 year, and it never got as bad as it was. That's kind of interesting, because my brother had like what's it called, those pills? They were like immunotherapy pills, and he put them under his tongue and stuff, and they started swelling up the first month. And it was like pollen and like some other stuff. And he did it for 3 years, and now he can actually be outside without sneezing somebody to death. So it was like a big difference and a big power to be able to do immunotherapy like that. And I'm certain there's a lot of things we don't know, or a lot of things we know but don't release because it's not going to be good business, and particularly for the Americans. Which is one of the reasons why I'm not very happy with how the Americans deal with the healthcare system, because it's ridiculous. It's more like a patient not cured is a patient still paying. He genetically modified the bacteria to dissolve lactose and infected himself with them. Exactly, but that's what I'm saying. Like the self injection and the self experimentation seems to be a norm and not an exception to a rule when people are, let's call it, desperate or in a particular needs. So at least that's how I see it. Might be wrong, and might be a lot of scientists in the comment section going, "Oh, you're fucking stupid," and I'll be like, "Cool, just explain to me what you would do then. Would you? I know you go on mice, but like when it comes time for human trials, what do you do?"
For the amateur atomic gardeners, atom blasted seeds hadn't really produced anything interesting in their own backyards. It was way too difficult and dangerous to crowdsource the work on irradiating plants. Individual gardeners likely became impatient with the breeding through successive generations that was required to produce a truly viable mutant, and with seeds that were more likely to not germinate at all than to produce tomatoes of enormous size. Though there were some beneficial products of the movement. The Rio Star grapefruit, which
That's
is
the
now
one you were
very
talking about.
common, is just one example, which was bred in an atomic garden to have very dark flesh and sweet juice.
So I really want to know if there is any problems eating these things that have been created by radiation. I'd love to know if that is an actual problem, because for all we know, in 5-10 years, it's like everything that you ate that was irradiated to get to this point actually causes cancer. Like it's been a lot of these things happening recently, especially with the steroid abuse and use, which is another thing I'm really interested in, because I'm really interested in the athletic side of things. Again, athletics and nutrition are really important. I don't think we speak about it enough.
Also, most of the world's mint oil comes from a peppermint cultivar called Todd's Mitchum, which is resistant to certain fungi and was bred at Brookhaven National Lab's Gamma Garden. In fact, there are more than 3,000 registered plants that got to be the way they are because of radiation. At its height, there were many gamma gardens, but most have since fallen to the wayside. Only one country still uses a gamma garden to produce new varieties of plants: Japan. This is because there's more targeted genetic engineering that's made the practice practically obsolete. CRISPR can be
I
used
see.
to efficiently target.
Let's stop it there for a second. Yeah, I feel like radiation is extremely misunderstood. I mean, so is nutrition, and it's come out with numerous studies recently that it's just been a bunch of bullshit. That grains and eating in the morning and all those things were just marketing ploys. So, I mean, what do we actually know in the grand scheme of things? You see, the obesity epidemic is just vast, especially in America and in the UK right now. And it doesn't help that most of the stuff that we're doing have all been influenced by larger companies like Coca-Cola making Santa Claus drink cola all the time and not be green anymore, like St. Nicholas, or if we're talking about Tony the Tiger telling everybody that Frosted Flakes are good for you, because they absolutely aren't, or Mr. Beast telling everybody that Feastables is a healthy chocolate option. We would love for you to have a healthier chocolate option and bring new customers into our store. That's kind of what I feel like they're doing, because that's exactly what they're doing and what they're trying to do. A lot of things might be misunderstood, but at the same time, there is a healthy dose of skepticism and fear needed for a lot of these things in particular. Because like animal fats and animal products were said to give you colon cancer and all these things. And now it's come out that animal fats and meats are actually some of the most healthy things for you. Oh, whoop-de-doo. Well, it's not like we didn't evolve to eat these things. So it's a little bit frustrating because you don't really know what within the research is actually good for us and what within the research is actually research against us for profit. So yeah, I mean, I understand what you're saying with it being misunderstood, but I don't know whether it's misunderstood on purpose. Radiation can definitely be very dangerous, but most people don't understand how. No, that's completely true. And I'm not saying I understand how. I'm arguing for the side that we don't quite know if they fucked us over as well. If it's like, oh, if you're eating these many strawberries of the radiated kind, then you will actually start deteriorating something in your body, etc., etc. I don't know any of this, right? And I also don't know when it's dangerous and when it's not dangerous. When it's maybe an atomic reactor that's leaking, oh, that's super dangerous. But if it has this and this and this, it's not. So that I'm not going to sit and say that I know of, but I'm seeing it from a skeptic's perspective in that sense. Well, I mean, maybe a realistic perspective.
Multiple genes in plants and change the expression of other genes. This does the job of atomic gardening without relying on the randomness of the mutations. But that's not to say that radiation isn't used at all in the modern era. Today,
Okay,
radiation
that's
is
interesting.
still used in crops, specifically food irradiation. Ionizing radiation is used to kill bacteria, mold, and other pests in food. It can also help slow down the aging of food like fruits and vegetables, which can also allow them to be shipped over longer distances.
This is another thing I've had a little bit of a problem with. For example, if you purchase something at the market, the stuff goes bad really quickly often. But if you purchase something at like let's say a supermarket, it stays good for a much longer time. And if you're having things that stay good for a longer time, is it really better for you, you know? Is it really... is it really good for you? Because like preservatives, we found out a lot of the E numbers have been really bad. And I'm certain a lot of preservatives are bad. And I'm certain there are some preservatives that are good, like smoking them or like dry aging or whatever you want to talk about. Like there's probably a lot of good and a lot of bad ways of aging things and letting things become older with, let's see, natural timing, like drying fruit, etc. Or pickling or salting.
The FDA has evaluated the safety of irradiated foods for more than 30 years and has found the process to be safe.
I'm sorry, but I don't really always trust the FDA. Like, come on. Like, if we go and search up all the things the FDA has said was safe, that isn't safe at all. I mean, it's better than nothing, but the FDA, I feel like, has a lot more monetary gains of these things.
Safe. The World Health Organization, the CDC, and the U.S. Department of Agriculture have also endorsed the safety of irradiated food. It's been used on everything from meats like beef and pork and chicken to fruits and vegetables and various spices. It's important to note that irradiation does not mean it's radioactive. The radiation passes through the food, leaving no lingering traces of radiation behind. That being said, if you want...
No, the radiation is light enough that it doesn't cause mutations, but it causes harm to the bacteria and mold that has a hard time growing. So basically, it's like the solar dose is fast as venom. Only the dose determines the poison type of ideology.
To know if your food has been irradiated, you can look for the Radura symbol that the FDA requires on all foods that have been irradiated. This is an internationally recognized symbol, so even if you are outside of the United States, you may still find it along with the statement treated with radiation or treated by irradiation on the food label. So while radiation never was able to give us the X-Men level mutations we all wished for as kids, it was able to give us a few thousand new plant varieties.
Okay.
Thank you for watching Learn
That's an
Something
interesting
New.
one.
If you
That was a
enjoyed
really
this
interesting
video,
watch, by the way,
consider
Frank.
liking